Hello, it's Cliff here from Down Under. In this short video I want to go through a couple of key points and a couple of tips and tricks that will ensure that you better protect your machine from wear and tear, that will help maintain your machine. It's really worth making sure that you understand these couple of points. Cheers. So the first point I want to make is with your machine tool, and we're going to talk about lathes in this video, identify the vulnerable areas of your machine. There'll be 1 or 2 or 3 areas of your machine that are highly vulnerable to wear and tear. In a typical center lathe, it's this area of the bed here, and the front of the cross slide area here. That's usually the problem area. Depending on the unique design of your machine, there may be 1 or 2 other areas. Think about where the high pressure is, the most traverse is taking place, where it's subject to getting abrasive particles, and where a worn surface can cause a hollow that can trap more abrasive particles and rapidly file out and cause big problems with wear and tear. So identify the Achilles heels of your particular machine and give them extra care, extra cleaning and lubrication. I'll give you a few examples of that. So the Achilles heel of a center lathe is typically this area here that gets all the chips and grit and dirt and all the traversing and pressure. So regularly brush the chips away. Wipe the surfaces down with a clean rag or tissue and apply oil and spread it out with your fingers. There's no internal pressure system at all in this lathe on the slideways, and yet in 40 years there's been virtually no wear, just for spending a couple of minutes each day doing preventative maintenance. The cross slide is another area in a lathe like this that can get grit and dirt under that slideway, so you can make a very simple little cover just to keep the grit and dirt from falling in that area, and just a small job to fix. This is not going to happen, is it? Here we go. A simple little cover, some little screws in there with little undercuts and that fit in there, and you can click that in, drops in there, slides. For example, I mean, it's different for each different design of lathe, but something like that you can easily remove when you are doing the odd extreme traverse situation will protect that area. The rest of the cross slide can easily be covered and is not a highly vulnerable area. So it's just the front of the cross slide and the bed area here and here that really need to be kept clean and lubricated. Well, I bought this center lathe new in the early 80s, so what's that, about 40 years now. It's been used regularly most days for 40 years, and I've been keeping the slideways in the vulnerable areas clean and lubricated by that method. And just to show you how well it protects the lathe, a 40-year-old lathe. So if I put a dial indicator on this area where it wears the most, this is where the main contaminants fall down, chips and grit, and they get under the carriage. And because there's a lot of pressure here and a lot of traverse here, you get wear in this area. This is where you look for wear on a second-hand lathe. But if I run the carriage down this end where it should be pretty well unworn, project forward, we should see a dip there where it's worn. Most lathes are quite badly worn in this area. So let's have a look. This is hundredths of a millimeter. You can see I'm in contact there, and I'll traverse that worn area to see how much the dip is, and you can see that there's virtually no wear in 40 years of use because I keep that area wiped and lubricated. Just a few seconds at the end of each day or the start of each day, and it's stopped wear almost 100%. Well, let's have a look at the Slant Pro for some areas that are vulnerable to wear. So to me, the first thing to look at is the bed, the main Z or longitudinal slideway. And behind this surface, round the corner there, at the back of that dovetail angled slide, is a very high pressure point. If you look at the weight of the cross slide and the carriage and the turret sitting on it, there's hundreds of kilo of weight there and quite a short length of slideway, and all of that weight is like a hook hanging on that small land, taking all of that weight. And that's also the area where particles of grit, chips, dust, concrete dust can end up sticking to that area, and it's out of view from the operator. So that's a high risk area. It's traversing a lot. Every cut is traversing with high pressure, and that's going to mean if you're not very careful, you'll get a rapid wear in this area. There doesn't appear to be any tear-site plastic coating there. It's just soft cast iron on soft cast iron, and any grit in there will tear away at that surface. So it's really important to brush the chips, especially if you're working with abrasive materials or with steel. Brush the chips away regularly, wipe it clean, and keep it lubricated. Don't trust your internal lubricating system to flush it out. It may or may not be working. So this is an area that I would be most concerned that this lathe will wear here quite quickly. Once it starts to wear and it gets hollowed in there, then you've got a real problem, because then you get grit and chips in the hollow, and it acts like a giant file and wears it out even more quickly. And it goes downhill rapidly. So if you want the machine to retain its accuracy, it's so important to brush in there regularly, wipe it clean with a clean rag or tissue, and keep lubricating it to try and hang on to that accuracy that you got when the machine was new. Right, well, let's have a look in the back of the Slant Pro at those important areas. So here's the back of the main bed slideway, and you can see that that surface is still in reasonably good condition. It's not all torn and scuffed, and that's because I've regularly brushed the chips away and dabbed a little bit of slideway oil on that surface so that we don't get all abrasive grit and chips in there hacking away at that surface. If you look closely there, you can see that it's the high pressure point. There's no tersite or plastic coating on the slideways. It's just cast iron on cast iron, and that would quickly tear to pieces if you had abrasive particles in there and it wasn't lubricated. This is also critical. The ball screw, it has a sort of partial cover over it to keep most of the chips away, but it's worth reaching over with your fingers that are clean with a couple of drops of oil and dabbing it on that screw to make sure that if the lubrication system isn't working, it's kept moist with slideway oil. So you can see here the cross slide, the X slideway, is much better protected underneath there, and a much lower pressure and wear problem exists there. Of course, I'm simplifying it slightly to try and make a point. The Z slideway also bears down on this surface and this surface, but there appears to be tersite there. It's a much bigger surface area, and it'll probably be a lot less wear on those larger flat surfaces. It's that area out of view that is the most vulnerable. And again, on the cross slide, on the X slideway, it's a very long length of slide, and it's well balanced, and there's probably tersite under that surface, and there's much less weight on it. So all of those factors divide the local wearing stress on the surface down to a much smaller degree, so you've got much less vulnerability of the cross slide. It would be unlikely to wear much at all. So you're looking at areas that are vulnerable. That's that area there of the Z longitudinal slide. If we look at the spindle, it's not lubricated in oil like most lathes, but it has installed grease in the bearings, and it's possible that coolant could fire in here and work its way into the grease and break it down, break the grease down. And I'm quite concerned that in this lathe the lifetime of the front spindle bearings will not be very good because of coolant ingress with particles of chips and metal that will break down the lubricating of that front bearing. I can't say how long it's going to last. So far so good. So in addition to the actual weight and presence of abrasive particles when assessing wear and Achilles heels of machines, you've also got to look at the ratio or the proportion of the slideways. If you look at the Z slideway, it starts here and it finishes just here. It's very short. It's done to keep the cost of the machine low and to keep the size of the machine low. But it's a real compromise, because if you look at the ratio of width to slideway length, it's very poor, and so it can very easily what I call rack. And I'll show you that on a drawer to try and explain it. So on a drawer there's a ratio here between the depth or the length of the slide and the width of the slide, and if it's very wide with very little depth of engagement, you get what I call racking. That is, let's have a look at this. So it racks one way and the other way. I don't know if that's showing up very clearly, but effectively if you pull on one side down the edge here, rather than sliding, it racks over and jams. If I pull in the middle, it slides freely, but it'll rack and jam over to one side because the length of engagement relative to the width of engagement is very poor. And we have that problem with the Slant Pro. The length of engagement this way relative to the width of engagement this way is very poor, and so you'll tend to get a racking of the whole carriage sliding on the bed every time you change direction, and that's really a bad feature because that'll cause wear in this high pressure area down there. So it's even more important to keep it clean and lubricated so that this Achilles heel exacerbated by the ratio of the slideway is minimized as much as possible. And if you look at the X slideway with that ratio point in mind, you can see it's very long compared with quite a narrow width. The ratio is much more in your favor between the length and the width of the slideway. Now that means that the chances of it racking and the high pressure point wear is going to be much less. Also the weight is less, and so I'd be a lot less worried about the X slideway on this machine, 10 times more worried about the Z longitudinal slideway. And that's also the most difficult to recondition. How are you going to remachine that surface down the back there? You'd have to completely dismantle the lathe. It would be a major task. So another factor to consider is how valuable is that slideway, and a bed slideway on the lathe is often a very valuable slideway. I can imagine some of you are thinking, yes, but you've got internal lubrication, you've got pressure lube coming from the inside. You know, in this case you've got this pressure plunger and oil lines feeding inside the slideways. They should be pushing oil out and blowing out any chips and keeping it lubricated, and you'll never have any problems. Well, that's great in theory, but the reality is that all of those oil lines don't always work properly. Some of them feed the area really well and others don't. And some areas that aren't important get all the oil, and other areas where it's the most important don't get enough oil or don't get any oil. the system can become blocked or damaged. It can burst a leak in it. It can get gummed up over time and stop working. It maybe never worked well in the first place. And you've got to remember, these machines are not made to high class Swiss tolerances. They're put together, and often there's abrasive particles and grit and dirt in the actual lubrication system. So you really don't want to rely 100% on that. It's better to have a backup plan in the main vulnerable areas, the Achilles heels of the machine, and do some additional manual lubricating. Well, what about wipers? You know, you think this is a great idea. Little rubber type flexible wipers, like on this lathe, or the old style felt wipers with cover plates over them that can soak up the oil. You can apply oil with them and theoretically wipe off the abrasive particles. They sound brilliant, and I'm sure in some situations they work, but long term, are we going to maintain them? Do they wear? Do they shift? Do they get loaded with abrasive particles? Do they distort away from the surface? You know, I'm not convinced that long term they make a lot of difference. If you don't clean your machine down manually, then wipers are probably better than nothing. Alright, let's just do a little experiment. We've got two pieces of aluminium representing a slideway, and that's sliding on there nice and smoothly. We're going to use this to represent a wiper to see how well it works. So let's put some chips and swarth on this surface, representing what comes off your machine and concrete dust and so on. We'll put the wiper there, come back to here, we'll spread that over the surface, and we'll do some traversing. Keep putting this back over it. So far it seems to be working quite well, but on the third stroke I started to feel abrasive particles getting between the surfaces. And already by the time I've just moved it 5 times, you can see scores developing in that surface. So see the score lines there? So what's happening is the very small abrasive particles are getting through, are getting underneath the wiper, and are starting to cause some tearing and wear after just 5 movements. Now you could say, oh well, that wiper wasn't contacting very well and was letting particles through, but in reality that's what happens on your machine. How often do you check the wipers have not worn and are seating 100% and haven't buckled away? In reality, what happens is the wipers may work well if they're good quality wipers and installed correctly for a period of time, but in most situations they only work partially, and they may even trap the particles under there once they get through. And so while they're reassuring to look at, in practice they probably don't do much more than wipe away the large pieces of chips. The really small abrasive particles that do the real damage, you know, the concrete dust that's in the air, that is probably not wiped away very much at all by wipers. Then you've got accordion covers, barrier plates, barrier covers, separate plates, covers, sliding plate covers, and these are very effective at keeping at least the large particles of chips and swarth off your slideways. But for certain machine tools like a lathe, in that critical Achilles heel area, especially the bed slideway where all the chips come raining down, it's very difficult to protect that, and you need to do a backup of manual cleaning and lubricating. So the way to protect your machine is to have a backup plan think of the areas that are highly vulnerable to wear. For example, this area in the Slant Pro. So regularly brush the chips, because they gather there, they fire there, and they build up in a pile there, and they become pressurized on the slideway. So regularly brush them out, and then clean that surface behind there with a clean cloth or a tissue, and then run oil over that surface with the clean hand, clean finger, wipe it on that surface. If you do that at the start and the end of each day, and once or twice during production, it's only a few minutes work overall, and it will give your lathe or machine tool much longer life. You might get 1% of the wear than you would if you were unaware of that Achilles heel vulnerable area and just neglected it, because the wear rate is exponential once it starts. But if you stop it from starting, your wear may only be 1% as much. Well, let's have a look at the wear on this Slant Pro. I've had it a few years now, but I've kept it clean and well lubricated. So we'll fit the dial indicator there, so we're projecting it forward from the carriage onto that highly stressed bed wearing area. We'll bring it in contact there. So let's just zero in on 0. Now if I go to the Z traverse, if I change direction, see there's really no racking there. That's really good. And then I'll traverse into the area where it would be most likely worn. So the slideway is sliding in the area that should be unworn and generating a straight line. And if that area is worn, you'll see a hollow appear, and then it should wind back up again to the unworn area towards the end. That's really good. I'm really pleased. So that highly stressed area has been effectively protected so far by the regular cleaning and lubricating. So if some of you guys have had a Slant for a few years, you've done a lot of machining and you hadn't realized about that, do that test. I'd love you to do that test and put it in the comments below. So you know that draw racking effect that I was talking about, well, it is reduced somewhat because of the sheer weight of the load on that narrow slideway down there, because the turret and everything adds up hundreds of kilos of weight. It's less likely to rack and jam. It's probably effectively clearance at that point, but a very good high pressure point on that top slideway, which is stopping it from racking and jamming. So that's actually a positive. One of the negative factors is actually also a positive. So if somebody there has got a Slant Pro like this and you've been using it for several years, machining steel or getting abrasive particles in there, I'd love you to repeat this test and put it in the comments below. It would be good for us to learn about how these machines are lasting, good for the general knowledge of Tormach Slant Pro owners. You've probably noticed this cover plate, this sheet metal plate that I folded up to help keep the chips from firing over that area and getting jammed in underneath the slideway. And it gives you some protection, but it doesn't protect in the front of that plate. I can't make the plate any longer because obviously it would contact on the headstock. So that's as wide as I can make it. It probably gives you, 30 or 40% protection, but it's only limited protection. You really need to manually clean in there, wipe it out and oil it regularly. That's probably worth doing just to give a little bit of protection, but it isn't the whole solution. While I've mentioned that bottom gib there, my thoughts on this is don't have that gib snugged up too tight, because it's going to add pinching friction to a slideway that is very small in length and large in width, and you've got this draw jamming effect. You want to have a reasonably clear gib with lubrication on there so that it doesn't add to the racking problem. Obviously you've got to have it adjusted up fairly close, but don't have it pinching on there. If you've got a turret, that adds a lot of weight and will make the racking less, so you can get away with a less close fit of that gib. So for the Slant Pro, traverse right down one end, the tailstock end, wipe down these surfaces, the 4 sliding surfaces and underneath, and lubricate it with slideway oil. Then come right down this end and then wipe those surfaces with a clean rag or a tissue. Wipe off all the abrasive material and dirty oil, put new oil on, and as well as running the pressure lubrication system. Obviously this is just an additional backup cleaning and surface application. I've just been running acetyl parts, and you think, oh well, there's no abrasive particles coming off there, but start up in the morning, did the usual wipe, and if you look closely at that, there's little abrasive particles in there, as well as the oil stained with the worn cast iron. Well, thanks for watching this long video. I try and keep it as short and concise as I can, but then I feel like I'm not covering everything. I'll just quickly go through cleaning and lubricating this lathe at the beginning of the day if the job's not urgent, or at the end of the day if it was an urgent job. So with a little swath brush, just a little paintbrush, just quickly brush off all of the major particles off the slideway. Grab a tissue, wipe down the critical surfaces, the main slideway surfaces, the tailstock surfaces. Get some slideway oil. I use Vactra number 2. Run that over the surfaces. Spread it out with your finger and over the slideway surfaces. Now back the carriage right back to the tailstock. Expose this is the most important area now that we do. Wipe off the chips, and you can see already this one tissue is pretty gnarly. Wipe down the critical surfaces, wipe down those surfaces. Just doing it really quickly, but you get the idea. Until the surfaces are clean, put the oil on, spread it out, and run it back over there. Now that literally takes, probably 1 or 2 minutes, but it's time worth spending to protect your machine tool's value for the long term. Thanks for watching, guys. Cheers. Thanks for watching that video. Let me know in the comments if you've got any more tips and tricks and information to do with machine tool maintenance. Cheers.